Great. I would say we're ready to go. I think we can start the stream.
Yeah, we are live.
Great, thank you. Hello, everyone. Welcome to today's EIP-7928 breakout call. It's the third breakout call today, and we have three things on the agenda. The first thing we want to discuss, which was already kind of a little bit discussed last week, but today we wanted to decide upon it, is are we going for a block level access list hash in the header, or do we want to switch it out for a block level access list root, which would then, mirror the existing trie structure we already use for receipts and transaction and so on. But of course, at the moment we use the hash, so the default might be we just stick to that, but very open to discuss that. The second point is how do we want to handle transaction self-destructs? There are basically two ways how to handle them. Either we include them and make it explicit that self-destruct in the same transaction is happening, or if you followed the last messages from Jared in the Discord, basically he's arguing for just including the address of the self-destructed account and not including anything else. And the last thing we can discuss today is an idea that Jared brought up, or Gary brought up, which is including intermediate storage account, including account storage routes into the block level access lists to speed up the hashing. Those are basically the 3 points, and then we can go into client updates as usual. Great. Let's start with the first topic on the agenda, which is block level access list hash versus block level access list trie or root, and putting everything into trie. And let's see, would be great, Jason, it would be great if you could give us a quick intro into why it would matter for precomps and what do you actually expect getting from this change, from moving from the hash to a root.
Yeah, absolutely. So I guess in the world of precomps, there's different flavors. Like we start with the basic being inclusion, which are pretty trivial to prove today using the existing tries. But as we move towards execution, there's different ways to do it. But really, an execution precomp would be a guarantee on the post state. And you can do that technically today using the existing tries. And what I mean by that is what we care about is being able to slash the proposer on chain and by proving that they broke their promise. And when we're using the existing tries today for execution precomps, it's a very disorganized and scattered proof. Like if your transaction that you're committing to affects many accounts across these different trees or tries, then there's a lot more margin for error. There's kind of data availability issues if the proposer isn't committing to every single thing that was touched. And for all of these reasons, one other important reason is a lot of the times we care about what we really care about is post-transaction state roots and not like post-block roots. So I think there's some information that's lost if we're only trying to prove against the final state after the block executes. So for all these reasons, execution precomps are really done through intent style programming, and that's like a burden on developers, kind of adds friction. And the proposal of using roots instead of hashes for the BALs is that it would be pretty trivial to prove from the smart contract. And the way that you'd organized it, Tony, would be a pretty straightforward commitment to a root to cover like every piece of state that's touched.
Awesome, thank you. So just to summarize, it feels like there are 3 points. If we move from a block level access list hash to a trie, we would make the life of preconf provide us easier because the proof would not depend on transactions touching the exact same state in the meantime, but we can get more granular and prove against a certain state at a certain transaction index. Then the proof would become cheaper because you wouldn't need to input that much data anymore. And also easier because it would just be one single proof against one object that we have. So I totally get, I can totally see those advantages. What would you say against the counter argument that the block level access list might be already enough because in case you want to slash a proposer, you would just need to input the entire block level access list as call data.
So, I mean, I definitely see that possible because you only have to slash them in the worst case if they did break the commitment. Maybe I'm just not as clear on like the size of this, like gas wise. Is that reasonable to be able to do?
Yeah, I think it would be. Yeah, because the block level access list seems like it's around 50 kilobytes to 60 kilobytes compressed. I think that's already on the upper end. And let's say 2x for uncompressed, so 100 kilobytes. Currently we support around 900 kilobytes per block compressed, call data. So this would be something that would still easily fit into the block.
Yeah, then in that case, I mean, as long as it continues to be scalable, like if the block size increases and the BAL also increases, if it's still able to fit in call data, I think that's definitely a good backup option. But
yeah, it's not only fitting into call data, we also need to fit in the computations needed to eventually prove it on chain, right? I mean, yeah, this would not be that much. We would just hash everything and compare the hashes and then prove it against the parent block hash. But yeah, I'm curious to hear of other clients. What do you think about this? Another point I heard from Vitalik was putting it into a try would be a good idea for partial stateless nodes. Because imagine you're a partial stateless node and you only care about a certain segment of the state, for example, specific addresses, and you don't want to download the entire block level access list, then someone could give you parts of the block level access lists that you care about together with a proof against the parent hash. So this might be another use case where a try versus a hash might be better suited. Yeah, so I'm curious, do client teams have an opinion on it, especially since it would mean introducing yet another try, which was one of the arguments I've heard.
Yeah, I wouldn't say I'm like strongly against it, but I can't say I fully understand the purported benefits. And yeah, the added complexity is also, I mean, the proposal is already like turning out to be complex to performantly implement and comprehensively test. So yeah, I mean I want to learn more, but yeah, kind of lukewarm about it right now, personally.
Yeah,
I
Dragon?
guess, sorry,
Or
I guess
yeah,
one more
go
thing
ahead.
there's nothing stopping us from updating the BAL format in the future to support this. I mean, it's not easy, but we don't have to package everything, all the bells and whistles in a single hard fork. No.
This is true, yeah. Dragon?
Wanted to say same thing. Yeah, I think ball should be minimal, and it feels that introducing tree inside with the same fork with the ball seems like additional optimization that we can do later. So I would opt in with some simpler solution right now, and then decide if we need tree, what kind of tree. Maybe it's going to be binary tree, maybe some else tree. It seems unnecessary to add it in this fork.
Thank you. I'm also relaying what Marius is saying in the chat. He's also weakly against it. Yeah, just to summarize, it very much feels like the trade-off here is complexity versus this additional use case, or what it enables, making certain things cheaper and easier. Of course, at the cost of adding protocol complexity. Also, Karim is saying here in the chat that he also prefers to keep it as is. Anyone else an opinion on that? Okay, then I would say let's keep it for now as it is. I will also reach out to Vitalik to maybe he can clarify his points further on the testing call, because we have a section on updates on block level access list on testing call anyway. So it might make sense to get his input since he's not on the call today. And it would be great, Jason, if you could publish your post somewhere so that devs have some opportunity to get into the topic of precomps and yeah, determine how important it would be. Yeah, no worry, Lukas. The thing we just talked about is the first point of the agenda, the block level access list hash versus the root. But in this case, if there is nothing else, I would suggest we move on to the second point on the agenda. So the last opportunity for anyone to voice an opinion on the hash versus root topic. Great, then let's move on to the second topic, which is how we want to handle self-destruct. So as you might have seen in the last few days, I've modified the specs a bit because there were some bugs around edge cases, and one of those edge cases were self-destruct happening in the same transaction. So not send all, but a real self-destruct. And in the test cases, we planned to explicitly handle self-destructs by having a post nonce in the block level access list that is set to 0. So usually you would never see in the block level access list a post nonce of 0, but Rahul and me were thinking, okay, it might make sense to signal that a self-destruct happened by having post nonce 0. What Gerard was today saying in the Discord chat is that since self-destruct in the same transaction are basically no ops and they don't change any state, we should just only include them as if they were a read. So we include the address with no changes in the block level access list. Of course, we include the balance changes if something was sent through the self-destruct, but we would not include nonce changes or code changes. And I wanted to double check what clients think about it and what would be the best way to handle a self-destruct. Maybe Gerard, you could also give us your rationale behind.
Yeah,
your
for
thinking.
sure. Just wanted to point out also that I don't think there would be a balance change in this case because the
Right.
account,
Yeah.
yeah, it has to be non-existent in order for it to be deleted, created and deleted in the same transaction. Yeah, I think you summarized my main point well. Also another thing I was saying is that I feel like in every other instance where we have account fields in the BAL other than for storage reads. It's for a situation where the post state is different than the pre-state, and so having this special case for self-destructs kind of breaks this. It's sort of just not consistent with the rest of the design for BALs. Yeah, I'm not sure what direct effects that would have, but it's just kind of another, just seems kind of yeah.
Yeah, you're totally right. Yeah, the underlying question maybe would be, do we want to differentiate, by just looking at the block club access list, do we want to be able to differentiate between an account that is, for example, accessed through balance opcode or call opcode versus an account that is involved in a self-destruct? So it is deployed in self-destruct. And it feels like there is no we don't really need it, right? Because what we care about in the block club access list is really like, what is the difference between the pre and the post state, or what actually changed and what is the post state? And since there is no change involved, it might just make sense to treat it just like a read without any special meaning.
Yep. I agree.
Also, Dragan, to answer the question that you raised in the chat, why do we need special case for self-destruct? It does not remove the storage. The self-destruct that happens in the same transaction does remove the storage, right? It removes the storage that was there after the deployment, that you wrote to it after deployment. But compared to the pre-state, it will be the same. I guess that's what you're up to. So if you have a self-destruct in the same transaction, then the pre-state and the post-state should be the same because the account is eventually deleted. And the nonce would be reset to 0, which it was before the transaction. Yeah, it feels like this is like the cleanest way to go. But just to flag it, just reading the chat, what Philippe is saying, I guess the argument is to save space. Yeah.
Oh.
Yeah, go ahead.
I guess we should also include, like, so we should determine when you create an account within the same and destroy it within the same transaction, but it reads storage, that kind of seems like it might be an edge case worth addressing in the specs.
So an account that is deployed and then it reads from another account, for example, the balance, and then it is self-destructed.
I mean, like an account that is created in the transaction, it does something, it either writes or reads its own storage, and then self-destructs.
Yeah, this is interesting. Yeah, go ahead, Dragan.
Those reads and writes would not end up in the try anyway, right?
That's a good question. That's the question that I wanted to ask.
They
Does
wouldn't,
the-
I'm saying for test coverage, it's worth it to have that case be,
Yeah, definitely. We need
define
a
that case,
test of- yeah.
The question is, if account is created and some storages are accessed, does those storages get included in the ball?
Yes. If the account is not self-destructed, then yes. If the account is self-destructed in the same transaction, then no.
So that
So-
will be
so
a difference. That will be a big difference, because if you just but what if you like create account, then access some, just load the storage, you still want to have it in the reads. But if you create account, check some storage, then self-destruct, you don't want to have that storage in the reads.
Honestly, I think it probably is such a rare enough occurrence that it should just be included in the BAL and we shouldn't have a special case.
Yeah, I tend to
Yeah.
agree with that. So it feels like there are
Thank-
two cases. We deploy an account that then accesses something from a different account. For example, I deploy a contract that then accesses, I don't know, USDC, and then I self-destruct. Versus I have a contract that is deployed, it accesses its own storage or writes to its own storage, and then self-destructs, right? Because for the first case, if we change something in a different account, we still want to include it in the block level access list, even though the account that is calling is self-destructed. It's more about what do we do about the account that is in the end self-destructed. And there it feels like what Jared just said, we just include everything that is accessed along the way in the block level access list as a read. Okay, great. Currently the specs are off on that front because I just pushed something to the specs like yesterday. So you might see those commits with fixed self-destruct logic or something. I will revert those so that the specs actually match the EIP again. And I might also clarify that further in the EIP to make sure that we include all state, including addresses and storage keys that are accessed during until the self-destruct in the block level access list. Is there any other edge case we should think about when changing the EIP or the specs that I forgot?
I think you mentioned it earlier, but there was the other, just the stuff about the precompiles. Calling a precompiled address would be included as a read. But yeah.
Yeah, this is another thing that is underspecified in the EIP. Yeah, I agree. And it will probably be specified like all the precompile addresses that are accessed in a transaction must be included as a read, which would mean including only the account with all empty changes. The question is, do we really need it? Because, for example, we assume precompiles are warm by default, for example. Do we really need to know which precompiles are accessed? Because it's different for every other part of the state that actually has something on disk behind it.
To be honest, I'm not actually sure in Geth if the code path for executing precompiles would result in them being included in the BAL as a read currently. I mean, I could see the justification for omitting them. I don't
But
really, I personally don't really lean strongly either way, as long as it's specified.
what about if we transfer some value it to the precompile?
Mm-hmm. Yeah,
And it
this is
needs to be
different.
included.
In that case, you must include it. So if you send ETH to the precompile, we always have the balance diff of that precompile in the block level access list. It's more like, should we include the precompile as a read? For example, if a storage key is read, then we have the storage read change in the account changes object. If an account is read, for example, through the call opcode or static call or balance and so on, then we have an account in the block level access list with all empty changes. And what I would think is so we don't have a mapping to a transaction index for reads, right? This is important to note here. So we don't have a mapping from reads in the block level access lists to transaction indices, which would mean for precompiles, we would know, okay, this precompile will be accessed in this block, but we would not be able to map it to a transaction. Just like we cannot map any read in the block level access list to transactions. So I lean towards omitting the precompiles from the reads. Yeah, but I'm happy if it's like simpler to just add them. I'm also happy to do that.
Just imagine if we have balance opcode that targets precompile. So in that case, we'll have something different where we need to omit precompile.
That's true, yeah.
That case, yeah. For the calls, that's more specific to precompiles because there is some different path other than executing the contract. Yeah. To be
Good
honest,
point,
I would, I would include it, but I don't have strong stance here.
Thank you very much, Lucas.
I'm for omitting it because we don't even track it internally. I know that Geth tracks it internally, but we have a simple if in code and we can just not track them, which is just also additional optimization. So I would omit it. It's worthless information in my opinion.
Yeah, I agree with that, but it feels like it would be an edge case compared to how we track all other calls. Because suddenly we would be like, okay, now a precompile is called, so we don't care.
Okay, but what's the purpose? Just completeness?
Yeah, or using existing code. For example, if you put the tracking function on top of the call, then you don't need any edge cases to handle a call to a precompile differently to a call to any other contract. At least in the specs, I think in the specs it's tracked right now, because in the specs there is basically a tracker that wraps around all the state changes, and it doesn't differentiate between a precompile being called or any other contract. If I remember correctly, I would also need to double check that.
And if we compare this behavior with access list, we are including only the accounts from, not all accounts from access, but only accounts that got accessed. So it's like a different notion, but yeah.
Right, yeah.
Yeah, you can argue that you can remove all the accounts that are found inside access list. I don't think that nobody wants that, but just for the argument's sake.
Yeah, currently we treat, for example, no matter if a balance opcode happens or a call opcode, we treat it exactly the same. And here, for example, if a transaction calls the balance of a precompile, then we would need to add it, right? No matter if we decide to omit the precompile reads or not, we would need to add it because we do want to know that this contract is going to be read. But on the other hand, if a precompile is called doing some computation, then we would need to manually omit it. And to me, right now, it feels like it would be cleaner to just keep them in there. But I can see the argument why this might just be unnecessary data if this precompile is like called, yeah, with something like call or static call.
I mean, it seems like it would be relatively easier to, if you are tracking it, just have an exception and not log the precompiles than to, like on our side, to change stuff so that we are tracing these accesses. Yeah, it just seems easier to the other way around, I guess, and also the data isn't really useful.
So you would also say we should omit the reads. So every time when a precompile is accessed through call or static call, it should not be included in the block level access list. But if it is accessed through balance or Xcode size or something, then we should include it.
Yeah, I think so.
Okay. Any other opinions on that?
Yeah, I'm not sure if it was easy to type, but yeah. In that case, we will have like the different behaviors depending on if it's call opcode or it's balance opcode or some else opcode.
Right. Yeah, I have no insight into client code, but I can definitely tell in the specs and the execution specs, this will make things a little dirtier. I guess there will be a simple way to change it, but this is the first time I would really have to differentiate between call and balance, for example.
I guess I don't have a super strong opinion. Like maybe if I could kind of look at the code a bit more, and if it turns out to be like a lot more complex, then yeah, I just need to review it really to kind of determine.
Yeah, sounds good. I would say for now we just keep it as is. Right now, it's kind of underspecified in the EIP, but I will add some proper specifications on that. But right now it would be tracked. So if it's accessed through a call, it's in the block of access list, and if it's accessed through a balance opcode, it's also in there. And if the precompile even sees a balance change, it's even in there with a balance change mapped to the transaction index. We can still reevaluate that decision in 2 weeks. I think it's good that we brought it up, and clients know that this is something we should look into and get some clearance on it. But then I would say let's just keep it as is, and if we decide in 2 weeks that we were wrong and we should actually do it differently, we can still do it. Great. Yeah, this was the last topic we had on the agenda. Last thing would be just client updates. Should we directly start with Jared Gaff again?
Yeah, sure. I think we had one more thing we wanted to talk about actually. I brought it up in the chat today. So there was this idea in the BAL there's this idea to commit in the BAL to the post state try route for storage tries. And essentially what that would enable us to do is fully parallelize the account try and storage try hashing. And I had brought that up because that was a suggestion from Gary on our team, but just wanted to say that it's not clear from the Geth side whether what the benefit of that change would potentially bring. But the reason I brought it up in the channel was to just try and put it on people's radars as something to explore. And we will definitely be doing that. Yeah.
Okay, yeah, this is interesting. Just to summarize, this would mean the block of access list would additionally contain for each account the post storage route of that account.
So yeah, so if the account had modified storage, we would include the root. I mean, we could of course include the root for every account, but we could also it could be limited to ones with modified storage.
Okay, and it will be the post state of the state after the block, and not
Yeah,
for each
exactly.
transaction, right? Okay. Yeah, this is definitely interesting. Curious if other clients, we don't need to decide upon that today. And I think Gary even said he wants to keep that client level optimization. But yeah, curious if other clients have an opinion on that or thought about it. I see Karim advocating even for putting it into the block level access list, I guess.
Yeah, I think in order to optimize this computation, I think it would be nice to.
I guess I'll just say that my impression right now is that most of our bottleneck with the state root update is in loading the intermediate nodes. So it's not clear in the end how much being able to fully parallelize the updates between the account try and the storage tries will bring. But
I think in Bezo we have this kind of preloading, so we can preload the intermediate node, and today the main part is doing the Ketchak computation of the intermediate nodes, and mainly also for the account part because the storage are done in parallel. So I think if we can at the same time compute the state root of the tree account, I think it will help for performance, but I'm not completely sure.
Yeah, this is definitely an interesting change. I think we should proceed with it in that we first get some more data, how much we would actually get from that. Keep the design of block level access list as it is right now, and just keep it in our mind that this is a simple optimization, because just in terms of additional data footprint, it wouldn't add that much. So it would only be like 32 bytes per changed account. So this would not be the problem. But yeah, let's keep it as it is for now. And in case we ever need to speed up the hashing, then we can still add it.
yeah, I agree.
Great. Yeah, thanks for reminding me. Almost forgot that point. Any other opinion on that? If not, I would just suggest we continue with the client updates.
Yeah, sure. I can give a brief update. There's not too much that has changed from our side to report here. We're working on improving the performance right now, and assisting where possible with the DevNet work. So right now, most of the bottleneck for us is in Geth is the state root update. So that's where we have and will be focusing on in the immediate future. And yeah, that's it.
Thank you. What about Nethermind?
Hi. On my side, just trying to get our implementation to pass the execution spec tests. Just debugging a few differences in the encoding format. Yeah, that's it.
Thanks. Yeah, and just to add on that, also one of the execution spec tests is now wrong, the one affecting self-destruct. So ignore this one for now. Rahul will fix that as soon as I fix the spec, just as a notice. Let's continue with Bezo.
Yeah, so today we implemented the engine API. We are passing the reference test. We are trying to run a local DevNet with Get and Bezo. But for the moment, we can see that the block created by Bezo are refused by Get. So we are trying to investigate why. But I'm not completely sure, but it seems that the block created by Get are accepted by Bezo. So the next step is to debug and understand why our block list is not valid.
Interesting. So this might be something we didn't catch. We didn't call with the test yet.
I think yes, but for the moment we just saw that before the meeting, so we didn't have time to check more. But I feel that yeah, maybe we are missing something in the test. Yeah.
Okay, thank you. Aragon. Is someone from Aragon here? Otherwise, let's continue with Ref.
Ishka?
Yes, not much we got to do concerning the changes. We were running the new sets of the tests, and like it works pretty well with the consumer LP, but we have some blockers concerning the consume engine. We are currently looking into the logs and trying to investigate the causes. We'll come to a conclusion soon, I believe. Yeah.
I'd like to add
Yeah,
add
go ahead.
something about the test too. The latest release, so if it's for consume engine, we do have updates there. We were using v4 instead of v5. And so I'd like to get a new release out that has all of the updates. And I'm planning on getting this out by today. So look out for a new release of the tests.
Awesome. Thank you very much. Great. Is there anything else we should discuss on this call? Something we should bring up? If not, I would suggest we can end the call at this point. Great. Then thank you very much, everyone, and see you on the next call in 2 weeks.
Right.
Bye.
Thanks. Bye.
Bye.